Hello. So today we are going to be doing lesson 9 of module 6. This is actually the very last lesson in this module. It's a pretty short one, but today should be fun because we're going to get to create a picture graph or a pictograph, and then we're also going to be able to take some data and put it into a line plot. So let's take a look at number 1. Number 1 says 4 children went apple picking. The chart shows the number of apples the children picked. So we have a couple names, we have the numbers of apples picked, and we can see that Roxanne doesn't actually have an amount here. So looking at this, the first thing we probably should do is to complete this table of information. So how are we going to figure out what she picked? Well, I can see that Stuart has 16, Trisha has 12, Philip has 20, and I have a total of 72. So to figure out what Roxanne picked, I'm going to have to add these up and then subtract them from the total to find the difference. So I'm going to go ahead and stack these 3 amounts. And I have 6 plus 2 is 8, and 1 and 1 is 2, plus 2 more makes 4. So 48 apples were picked by the other 3 students, and so if I subtract that from our total here, 72, it'll tell me how many Roxanne was responsible for. So I can't take 8 from 2, so I'm going to take a 10 from the 7 and add it into the 2 in the ones column, and I have 12 minus 8 is 4, 6 minus 4 is 2. So Roxanne was actually the most efficient picker. She had 24 apples. Find the number of apples Roxanne picked to complete the chart. Done. Now we need to create a picture graph below using the data in the table. So they've set it up with apples picked. Along the y-axis, they have the number of apples picked, and then they have the label down here for the children's names. So we have, move this up so I can kind of see it. All right, so we have Stuart, and we have Roxanne, Trisha, and Philip. All right. Now, from here, we have to decide what symbol we want to use for our apple picking. So I'm going to draw an apple, and I'll put a little leaf on it. Now, with picture graphs, one of the things you want to make sure you do is don't go bananas and draw, apples that take 15 minutes per apple. I'm sure it would come out amazing, but it's going to end up creating a lot of work for yourself. And oops, I put my symbol in the wrong spot because I was just noticing, what caught my eye was the amounts in the table. And I'm thinking to myself, when I drew that little apple, I do not want to draw 72 of those things. So I'm going to move my apple over here where it belongs. Okay. But I'm also need to decide how much should each apple be worth. So when I look at our data up here, I have a 16, a 24, a 12, and a 20. Now, looking at these numbers, what I want to do is think to myself, how can I kind of simplify this picture graph? How much what's the max that each apple could equal so that I could still show my data? I do notice they're all even. So I could do 2. That would mean that for Philip, I'd have to draw 10 apples. For Roxanne, I'd have to draw 12. So I wonder if I could go a little higher. If I did 3, that would kind of make 16 a weird one. 3 would work for these 2, but not this one. What about 4? So 4 times 4 is 16. 4 times 6 is 24. 4 times 3 is 12. 4 times 5 is 20. I could simplify this picture graph by making each apple worth 4. So I'm going to say 1 apple is really equal to 4 apples. So when I draw Stuart's, I have 16 up there. So 16 divided by 4 is 4. So I'm going to draw 4 apples for Stuart. These kind of probably look a little bit more like pumpkins, but there's no bad art, right? Except maybe in this case. All right, Roxanne has 24. So Roxanne, now remember, I want her fourth apple to be right about where Stuart's is, so that I can look at them all and kind of see who is truly, got the most apples, or who truly has the most apples. Okay, so there's Roxanne. I should have just done boxes. And then I have Trisha has 12. So 12 divided by 4 is 3. So I'm going to draw 3 apples for Trisha. I would imagine that when I see your homework, if you have to draw these, I will be impressed and think you've done a better job. Philip has 20. So 20 divided by 4 equals 5. So Philip gets these 5 apples. That gets him up to 3. Here's 4. He's pretty level. 5. Okay, so there's our picture graph with apples picked. Now we have a couple questions. How many more apples did Stuart and Roxanne pick than Philip and Trisha? So remember, Stuart and Roxanne are here. Philip and Trisha are here. And how many more apples is telling us they picked more than these two combined. And how many more than tells us we're going to need to subtract those totals. So we're looking at Stuart and Roxanne. So Stuart had 16 and Roxanne had 24. 16 plus 24. And then Philip is 20 and Trisha was 12. So when I go to add these up, I just need to be careful, make sure I get the correct amount. So there's 40. And then 20 plus 12 is 32. And when I subtract those, right, I've got 40 minus 32. We end up with 8 more apples. Okay. On B, it says Trisha and Stuart combine their apples to make apple pies. So Trisha and Stuart, we didn't add those together. And from there, each pie takes 7 apples. How many pies can they make? So I need to find Trisha and Stuart. So Trisha was 12 and Stuart was 16. So 12 plus 16, right? Because combine tells us we want to add, and that tells us that they have 28 apples. Now, each pie takes 7 apples, right? So if you're thinking about this, like, what kind of math is that? It's like they have this big basket of 28 apples, and they need to figure out how much goes in each pie. So what is that when we have to equally pass out amounts? It's division. So we would take 28 divided by 7, and then we would equal 4. That tells us that each pie will have 7 apples in it, and it will make 4 of them. 4 pies. Now, on this next one, it says, Ms. Pacho's science class measured the lengths of the blades of grass from their school field. That sounds fascinating. To the nearest quarter inch. The lengths are shown below. Could you imagine going out and measuring blades of grass? All right. So we need to then make a line plot of grass data. I think I liked the worm measuring one better. That sounded a little more interesting. Okay, a little gross, but a little bit more intriguing. So make a line plot of the grass data. Explain your choice of scale. So choice of scale means what intervals are we going to decide to partition our number line into? So the first thing we'll do is let's go ahead and make our line, and then we'll go back to the data. So when you make your line, you want to give yourself plenty of room to build up, right? So don't draw your line way up here. And then we're going to go back to the table, and remember when we go into the creation of that line plot, we need to identify the lowest, the smallest unit that was measured, and the largest, because those are going to determine our endpoints of the line plot. So let's take a look at what we've got. I've got a 2 1/4, which is pretty small, right? Let's see if we can find something smaller. I have a 2, that is smaller. And I don't have any 1s. Okay, so 2 is the winner on the smallest. So I'm going to go back here and put 2. And then we're going to find the largest. What was the tallest blade of grass? So I see that I don't have any 4s on this paper, but I have some 3s. And so I have the closest you can get to 4 in terms of the data that we're looking at here is going to be 3 3/4. And if we look, I've got fourth, half, fourth, half. So we're going to be needing to partition this line into fourths, right? And our largest one will be 3 3/4. All right, so let's start making those tick marks. So we have 2. The next one would be 2 1/4, right? If I make another jump and add another 4th, that would give me 2/4, but we're not going to write 2/4. We are going to write 2 1/2, because 2/4 is equivalent to 1/2, and this is a unit fraction, which is a benchmark fraction and more commonly stated. If we add another 4th, right, a half and 2/4 and 1 more 4th, you have to kind of think of it that way, will give us 2 3/4. And then I have 3, right, because 3/4 plus 1 more 4th will make a whole, just 3. Ooh, I might have to bump that one out. Let's bump this one out more to the end, because my spacing is not the way I want it. Okay, I was close. All right, so then I have 3 1/4, right? And here's my 3 1/2 and my 3 3/4. All right, so now we have to plot all this. So I'm going to stack this up here, and I'm going to check them off as I go. So I'm going to try and make quick work of this, because you have all seen this before, and me putting X's on a line plot is not the best use of your time, but I did want to make sure you were able to see the process, one more time. Some of us may have missed the last lesson, so I'm just checking them off as I go and plotting them as I go. That way I don't miss any, and it kind of turns into that little fun race. Which is going to be the winner? What is the most common length of a blade of grass? 2 3/4. All right. 3. Oh, I started putting X's because I'm putting X's here. 3 1/4. Okay. 2 1/4. 3 3/4. 3 1/4 is here, and 2 3/4. Okay, there we go. All right, how many blades of grass were measured? All right, so we can count up all these X's, or we're going to take a little shortcut. This, if you notice, is structured like an array. So we're just going to speed this up a little bit. I have a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. I have a 4 by 6, people. So if I have a 4 by 6 array, I can use what to calculate that? Multiplication. 4 times 6 is 24. So there are 24 blades of grass measured, and I know because the table, you can even say it, was a 4 by 6, which equals 24. See? Probably not the answer they were expecting, but valid just the same. All right, letter C. What was the length measured most on the line plot, and how many blades of grass had this length? So here they're using the word most, and they have frequently, right? That's that one that comes up the most. And who's our winner? 2 3/4 is the winner. 2 3/4 was the most frequent. And how many blades of grass was it? 1, 2, 3, 4, 5, 6. Because, let's just keep it going. It had 6 blades, that length. All right. And finally, how many more blades of grass measured 2 3/4 inches than both 3 3/4 and 2 inches combined? So I have to think 2 3/4, right, was my largest. That had 6. And then I'm combining 3 3/4 with the 2 inches. So 3 3/4 had 3, and 2 inches had 1. So that would be a 3 plus a 1. And again, just using that organization of parentheses is a great way to see the problem in an equation. 2 more measured 2 3/4. All right. This is it. So enjoy this last lesson in this module. Can't wait to see your graphs. See you later.